So if you have a conventional big inverter, you will have strings of panels. So you may have 1 or 2 strings of panels, which means all your panels are in series. If one of those panels gets shaded, the current through that panel drops, which means the current through all the panels in the string drops. So you lose a lot of power from just one panel being shaded.
So back to shading. With a string system, if one of your solar panels gets shaded by a branch or tree or telephone pole or whatever, then the entire string will drop to that same production of that lowest common denominator panel.
They all went out. Same thing with a string inverter. If one solar panel goes out, they all go out. If one solar panel is shaded by a chimney, they're all shaded the same amount. They can only perform to the lowest performing member.
So, how many of you heard that lie being peddled before? You can't have missed it because it's on nearly every YouTube video where they're promoting optimizers and microinverters, and it is a very big misconception in the solar community today. I'm not sure how they get away with this. I thought it was illegal to sell products under false pretenses, or lying about why people need to buy this product, or selling products through deception. But they're getting away with it, these big companies. I guess money talks, eh? The problem is that other people are following suit and also promoting that very same lie or misconception, and that misconception is what we've seen in those 3 short clips. The so-called solar experts are getting it wrong, either intentionally or unintentionally. So you will see the second and the third clip were both promoting microinverters, and so this is what happens when money becomes involved and there's lots of it to be made. So what we've seen in those 3 short clips was microinverter system. One panel is shaded, we lose 50% output from that one panel, but all the other panels on your roof continue to output 100%. Okay, well, they don't actually output 100% because they have a microinverter plugged onto them, which is only 97% efficient. So the efficiency and output of that panel drops immediately as soon as you plug any electrical product onto it, because no electrical product is 100% efficient. Then we hear that if you have a string inverter and a string of solar panels connected in series, and we shade one of those panels and that panel drops down to 50%, every single panel in that string drops down by the same 50%. That is absolutely incorrect. Here is what actually happens. If we have, say, an aerial post on the roof and it's shading one section of the panel in the middle, like this little leaf is doing, only that section of the panel will decrease to, let's say, 50%. The other sections of that panel will still output their maximum power in relation to the amount of sunlight they're receiving, as will every other single panel in that string. The panels in that string that are not shaded will continue to output 100% of the energy in accordance with the amount of sunlight they are getting. So this here is the biggest solar lie, or the biggest misconception out there at the moment. It has been going on for years and years, and it is simply not true. So these are so-called solar experts that are telling you this is what happens, and it's clear that these so-called experts have no idea how a solar panel actually works. That is wrong, and as soon as I get these bits of paper apart, that is correct for a string system. A string system, good quality panels, a good quality inverter like the Fronius is a far more efficient, or more efficient, not far more, but more efficient system than any system that has microinverters or optimizers, because a solar panel already has a built-in optimizer, and we're going to look at that right now. So for all you solar experts out there, and if you want to take me on about this, I'm happy to accommodate you. We'll get together and we'll do a side-by-side comparison, and we'll test out your shading theory, see if it actually works or it actually happens, and I guarantee you it does not. So, a little educational video for those that don't know a lot about solar, which seems to include the so-called experts in solar. Caveat to that, there are some out there that know the truth and have proven me correct, and I'm going to prove myself correct anyway, but there are some installers out there that know about the big microinverter optimizer lie, and they have done the test and they have their results. But for those of you experts that have no idea how a solar panel actually works, we're going to show you right now. So this is a 72 cell panel. It's 36 volts, 5 amps. Okay, so the panels I'm going to be using throughout my tests are over 20 years old, and I'm using them for a very specific reason, and one of the reasons is to show you just how far back this technology goes. The other reason is to do with those out there that say after 20 years your solar panels are put no good and they get put in landfill, so they're not green. Another solar lie, we'll get into that later. Okay, for the experts and for you people out there that want to know, this is how a solar panel works. In this case, the voltage is our working voltage, it is not the open voltage. We're only interested in the maximum working voltage, maximum working current of the panel to get our maximum power out. Okay, so here's what happens. Here we have a series of cells, 6 strings of them. Those 6 strings are all connected in series. Each one of these cells is capable of delivering 5 amps at 0.5 volts. Okay, this is working voltage, working current, 0.5 amps at, or 5 amps at 0.5 volts. Now, because they are all connected in series, as we can see here, the current value remains the same throughout the series of cells, but the voltage is additive. So it's 0.5 volts, 1 volt, 1.5 volts, 2 volts, and so on till we get to the end. Between here and here is 36 volts. So these little gizmos up here are called bypass diodes. These little gizmos are a far better and far more sensitive optimizer than an optimizer, believe it or not. The resolution on these, and you're probably not going to believe me, maybe even some that are actually glued onto solar panels, but the resolution of these diodes is 1 milliamp. As soon as it detects a 1 milliamp drop in this series of cells, where this series might have a fly or something land on it, and instead of 5 amps it only puts out 4.999 amps, this diode will bypass the other 1 milliamp to ensure that the 5 amps still flows through our solar panel and through our inverter. Don't believe me? Well, watch the next video and I'll show you. That's how sensitive these are. They have a resolution of 1 milliamp and they are the best solar panel optimizers, and they're already in the panel. Like I said, the people that designed solar panels knew what they were talking about, and that is one of the little diodes there that came out of one of these solar panels we'll be using in the tests. See picture top left hand corner now, and you'll see where it came from, out of that little junction box where those little magic parts are placed. So if we have some slight shading just over any one of these cells, it won't be able to pass the full 5 amps through it. So we only need to have the current drop down in one of these, and it drops down throughout this entire string of cells. So if we place some shade on this part of the panel, and this can only pass, let's say, 2.5 amps now, the other 2.5 amps will bypass through this bypass diode to ensure that the 5 amps still continues to flow through the other 4 series connected string of cells. That is what they're there for. That is how they work. There are some misconceptions that you have to get a lot of shade. Once you get a lot of shade on a portion of the panel, the diodes kick in, and that is where some of the losses is. That is not true. As soon as we get a 1 milliamp drop in any one of these cells, a slight bit of shading, even a fly landing on it, this has the resolution to pass 1 milliamp to ensure the full 5 amps still continues to flow. So the more we shade it, the more this will bypass the current to ensure maximum current flow. So what happens when we put 2 panels in series? What does it actually look like as far as the electrical circuit diagram goes? People will look on their roof, they see 2 separate panels and think it's doing 2 separate things, when in actual fact this is actually what it looks like. Now it looks like one big panel with twice as many strings of cells, and that's all it is. This red line here depicts where the positive of one panel is plugged into the negative of the next panel, and you can see our circuit is exactly the same all the way along. And the same thing happens in this situation. If we shade any part of this string of cells, current will bypass here and maximum current will continue to flow through the second cell as well, because that is the circuit we have. If we shade the middle portion of the panel, maximum current will flow through this one here, some will flow through here depending on the volume of shade, the rest will flow through the bypass diode, and maximum current continues to flow through every other panel in that string. That is how it works. Now we're going to go one step further in our tests than anyone else has gone before, and we're going to have a very close look at this happening in real time on a real panel. This is what we're going to do. Okay, here we have a solar panel, same one just as the last picture. What I'm going to do in my tests is I'm going to disconnect the bypass diode from the second string, leave it hooked into the first string, and then we're going to put in series an amp meter. So we're going to come through that bypass diode into the amp meter out of the amp meter and back into the second string where the bypass diode normally goes. This allows us to watch the amount of current flowing through that bypass diode in through the next lot of strings, and that way we can see how much current is actually bypassed in relation to how much shade is on this portion of the panel. But we're going to go one step further. Now we're going to have a really close look. What I've done here, flipped the panel over and got my die grinder and ground away the polymer on the back of the panel until such time as I reached the buzz bar, which is this bit here, across the first and second string of cells. I then lifted the buzz bar up, cut it in half. I've soldered some twin core cable to it, and that twin core cable goes to a second amp meter. Alright, so what we can do now is, as we shade this part of the panel or one of these cells, we can see how much current is still passing through this series of cells and how much is actually being bypassed. Alright, and this is how I know, because I've already done a series of tests on it, this is how I know that these bypass diodes have a resolution of 1 milliamp. I can get 1 milliamp to go through that bypass diode by very slight shading of one cell. So that's the resolution of our bypass diodes. Big box of tricks like this, an optimizer will not even come close to that resolution. That's why our bypass diodes, this little tiny thing here, is a far better optimizer than this big expensive box of tricks. And that has a second loss in it, the efficiency loss of that box. So that is going to be our test in the next video, and we can show you, as we shade this more and more, this section of the panel, we can see the current dropping here, we can see the current increasing here. That ensures that you don't bypass all the current, you still pull as much power as you can out of this shaded section of the panel. Okay, and what does that mean? That means it is optimizing. Okay, it will only bypass as much current than cannot flow through this string of cells. So that's what we're going to be doing. We're going to be looking closer than anyone has ever looked before, and you're going to see that the bypass diodes don't just kick in, they come in very, very, very softly in relation to the amount of shade, which ensures that you always get maximum power out of this section of the panel in relation to the shade. That power is optimized by this little component here. So we got that versus that, 36 cents, 75 odd dollars. Plus that is another loss due to efficiency. Alright, so that's what we're going to do in the next video, guys. So keep an eye out for that. We're going to debunk this bullshit, as I call it. And we're going to totally eliminate this lie through a series of tests on actual panels in actual situations, and you will see for yourself that this is probably the biggest solar lie out there at the moment. Okay, that is not what happens at all. That there is what happens in a string system. Okay, thanks for watching, and we'll see you next video. I should have that up in a few hours after this one. Go and watch it and be the first to watch the current flow through two strings of cells and the current flow through a bypass diode. We'll get to the truth one way or the other. Thanks, guys.